Hello guys. As a project gets more and more complicated, it becomes harder to present the steps, since it's harder to code without mistakes. There has been so many times that I had to go back again and then make corrections and continue. So trying not to reflect that to you becomes more harder as the project gets bigger. So in this video, I would like to go present the final code instead and go over each line and tell you what it does. What I'm going to present is making of a simple tech tree and its editor. This tech tree contains technologies connected to each other, and at the end you can expect to get something like this. To create this, we need three scripts: a technology script, a tech tree, and a TechTreeEditor script. Now let's start with the technology script. Tech object is a simple object that inherits from a scriptable object instead of the mono behavior, so that we can create and save instances of these technologies inside the editor. The tech is also going to create asset menu attribute so that we can create them in the editor through the menu. The tech currently contains only two variables, a description and an image. I'm thinking that these can be used in a pop-up window when its research is completed by the player. Now let's look at the TechTree script. A TechTree object is a collection of technologies and their connections in form of requirements. We can also describe it as a directed graph where the connections are only in one direction so that it cannot form a cycle, because if they did, the cycle would not be achievable since all requirements need to be met before you can research. Each nation will have different pace in technological progress, so each will have to create a copy of their associated tech tree and keep the track of the progress inside their own tech tree. This progress basically keeps how much they invested for each research. So tech tree contains technologies packed inside tech nodes. These are objects containing the associated technology, but also include requirements for each technology, as well as the research cost and how much it's already invested. And at the beginning, it's going to be 0. Finally, we have a UI position variable. Its purpose is visualization and nothing more, so that if we want to draw this tech tree, we can specify where each node is going to appear. Remind you, the connections will be independent of the position. The serializable attribute is necessary for the tech node. This is so the content of the node can be saved or visualized in the inspector. Now let's look into the tech tree. Tech tree also has a create asset menu attribute. It inherits from scriptable object just like tech. But you don't need to put the serializable attribute because it is already serializable since it inherits from a scriptable object. Then we have to have a collection containing all the nodes. I have thought several different ways of doing this, but at the end a flat list of nodes turned out to be the best way to store the tree. We are going to have several functions as part of the tech tree. We have an add node function where we will create a new node from a given tech and a UI position. And to do that, first we have to check if the tech is already presented inside another node. Now this will be performed by the findTechIndex function. And this function iterates through the nodes, and if the tech of any node is same as the given node, it returns the index of the node. Otherwise, it will return -1. Since I starts from 0, -1 is only possible if there is nothing found. If the add node function cannot find the index, it will return -1, in which case it is safe to add the new technology. So we add by creating a new tech node where the requirements is an empty list and the research cost is 0, at least for now. And then we have the delete node function. This too uses the findTechIndex. Then it removes from the tree using that index. But this might not be enough if it is a requirement to an existing technology. So then we have to iterate through the technologies in the tree, and if their requirements contain such a technology, we have to remove the requirement as well. The following two functions are used to check if the two tech nodes are eligible for a connection. We start with does leads to in cascade function. don't try to keep the function names short. They should be clear as much as possible within the context. So name like that is fine. Here, this code checks if the technology is required for another at any point in the tree. So for example, if you want to bake a cake, you not only need to know how to do baking, but also know how to harvest wheat, even though this is probably a tech that you discovered way back. This code takes two tags. One is going to be the query and the other is subject. Then it iterates through the requirements of the query, check if any requirement is identical to the subject. If it is, it returns true, and otherwise it calls itself, but this time with that requirement as the query. The original subject doesn't change, it's still the subject. This kind of function that calls itself called a recursive function. Since it is a recursive function, it will jump backwards in the tree until all the requirements and the requirements of the requirements are visited. If any of them is the subject, then it will return true. Next is the isConnectable function. This simply checks if the two texts can be connected. If they are not identical or if they do not lead to each other, then it returns true, meaning that there is no reason they couldn't be connected. And the last part of our tech tree is optional. I want to make sure that if a requirement was already connected to a previous tag, it doesn't need to be explicitly be requirement to a technology listed further down. In other words, we want to remove any redundant requirements. Now to do that, I coded the getAllPassRequirements function. This takes a given node, creates a hash set to store what will be discovered. And depending on the second parameter, it can store all the requirements into the hash set or leave it empty. Then it iterates through those requirements and calls itself for a particular requirement. As you can see, this is another recursive function and collects all the text from previous requirements. The final function is a correct requirement cascade. It receives the tech node index, finds all the requirements except the immediate ones. For each of them, then if the discovered texts are contained in the requirements of this node, it will remove them. Finally, we can start coding the visual things using the editor script. So I created a TechTree editor script inside the editor folder. Putting file inside editor folder is important. This tells Unity that these scripts will not be included in the final build, and they are only for the editor. So let's look into the file. First, we import the Unity editor and also Unity text because I identified this as the namespace in the other two scripts. It is important to keep the context clear, so I do that by putting this text system under the Unity text namespace. Then I set which objects is this editor script is for using the custom editor attribute. This time it is for the TechTree object. This editor object inherits from the editor instead of monobehavior. And then we have a pile of variables. Now these are only for adjusting the positioning and maybe altered as you wish. Then we have 3 vectors for scrolling and moving nodes. And finally we have 2 nodes which will store the nodes that are going to be actively selected or moved. You don't need to worry about these variables yet. They will become clear later. Now, everything about our tree will happen inside the inspector instead of popping up a new window. We could use the new Unity GUI tools, but then we would have to create more files. I think there is no reason to use the inspector to draw our trees. So whatever we draw, it's going to be inside the inspector. And it will be drawn during OnInspectorGUI function. So we have to override this function. First, we get access to the tech tree that we are showing from the target. Target is a variable that comes from the editor. Now the script that we inherited from. Then we cast it into the tech tree so we can use it in the rest of the code as a tech tree object. The next 3 lines of code receive the mouse events. First, we store the current event. Then we get the ID of the UI controller that the mouse is interacting with and store that interaction as a UI event. So the current event will reflect whatever the mouse is doing, and the UI event is whatever the mouse is doing for a particular UI element. Next, we set up the GUI styles that we will use. Unity has predefined styles, and Helpbox is one of them. It has a border, so it is perfect for our case to identify the end of the nodes. Now I'll create 2 styles. One is going to be the copy of the Helpbox, and the other one is with its title in bold italics. Now I will use the letter to indicate the selected node, and the first one is the rest of them. After we define the variables, we will need to start drawing the GUI inside the inspector. The first one is a scroll view area, so that we can have an empty area for our tree. We will achieve this with a scroll view and set the minimum height to 720 pixels. The width is by default stretches to the view. Then we iterate through the 3 nodes. For each node, we define a rectangle in the scene, which the leftmost corner is determined by the UI position from the TechNode object minus the scroll position. This way, changing the scroll position will move all the nodes by a certain distance. Then we draw a fold-out header group inside this given rectangle, and this creates a node with a fold-out option. I chose this so that we can maybe add a fold-out option later. For now though, I made sure the group was always in open position, assigning true to the second parameter. This is followed by the title and then the style. Now for style, we have 2 options depending on the selected node. So I created one-liner if condition. If the selected node is this node, then it uses the selected node style. Otherwise, it uses the node style. Though I must note here that I used Editor GUI, not the Editor GUI layout. The main difference between these two is that the Editor GUI elements allow you to define the rectangle where you want to draw, while Editor GUI layout places the elements depending on the next available rectangle. Then we have a label field to place our label for the research cost. To place this, we move the rect by next line vector. And this vector is on the y-axis, so it will be slightly below. Then we place an int field, which is going to take the research cost. Now the common sense suggests that I should place this inside the rectangle, but I found that it will conflict with other mouse events if I do, such as carrying the node, so I decided to make this controller hang on the side of the node rather than inside. It is easier to code this way, and actually I think it looks better. We do the same for invested research amount, but these are located below the cost, so we simply multiply the next line vector by 2 wherever we use it. These are followed by and fold-out header group to indicate that the drawing of this node is complete. But we need to draw the connections. Now to do this, for every tech node, we iterate through its requirements. First, we check whether this requirement is actually inside the tree using findTechIndex function. If this tech exists on the tree, then we draw a Bezier curve, starting from this node to the required node. The Bezier also requires 2 points to be able to identify where the tangents of the beginning and the end of the curve are. Since the tree is horizontal, we just add or subtract 100, I found 100 to be feasible, to point these tangents. We can also define the color, texture, or the thickness of the curve. Now this creates the curve. However, I thought adding an arrow could make it visually more pleasing. So I added two diagonal lines to create the arrow in the direction of the progress. And just in case we cannot find this requirement in the tech tree, I leave a log warning so we would know if the tech is missing. All these codes until here allows us to draw the tech tree. From here on, we will be looking into how we can use mouse events. We start with checking whether the mouse is inside each node rectangle. If that is the case, we check if the mouse is pressed. If so, then we check if the button pressed is the left mouse button. If the left mouse button is pressed, we set this node as the active node. We also store the offset between the UI position of this node and the position we clicked in the view. We will use the left mouse button to move the nodes. We will use the right mouse button to select nodes or create connections. So if the right mouse button is pressed inside this node, we set this node as a selected node and repaint the inspector so the inspector can be updated. If we do not repaint, the changes will not be updated until the next repaint. The GUI is not updated like the game is updated. It updates when an event happens, such as moving the mouse, etc. So we need to manually call repaint to see the change right away. If the mouse event is the release of the mouse button, then we consider if the selected node is a different node. Now remember, the selected node is updated when we press the mouse button. If we move the mouse to another node while holding it and release the button, then we should create a connection between the two. Or maybe there already exists a connection, in which case we have to break it. So we check if this node contains the tag of the selected node in its requirements. If that is the case, we remove it, also vice versa. If there is no connection, then we check if these are actually available for connection. If that is the case, then we add the selected node to the node's requirements. However, if this connection yields another connection redundant, then we want to remove that one. To do that, we simply call the correct requirement cascades function from the tech tree. This way, if we have a tree that looks like this, and if we make this connection, another connection will be redundant and it will be removed. With this, we completed part of the code that is called for each node. Now, this has already been a huge function, and in reality, this is a bad practice to have big functions. If you can, you should keep the functions as small as possible. The Visual Studio has a good tool for this. You can select a part of the code you want to extract, and while holding Ctrl, press R and M keys consecutively, and that will pop up the extract method form. But for now, I think it's easier to explain when everything is in one place. The following part is the code that controls the scrolling. Now, I decided that the middle mouse button will control this, so we will check if that is the case. If the middle mouse button is pressed, we store this in scroll start position, and if the middle mouse button is held, then the scroll position vector is updated with the difference from the scroll start position and the current mouse position. And then we repaint. And since everything, the node UI is drawn with the scroll position offset, everything will move in the inspector accordingly. Next piece of the code aims to draw a guide curve, so we can keep track of the selected node while dragging a connection. If the selected node is not empty and the user is currently pressing the right mouse button, we use the draw bezier function. However, this time between the selected node and the mouse position. So this code allows us to visualize the connection curve before we can actualize it like this. The following code checks if the mouse is dragging an active node. If that is so, it updates its position. So if the mouse is released, it sets active node variable to null, so that we can do this. So far we have coded all main functions required to shape a tree, except how we can add or remove the text from it. Now following will enable us to import a new text into the tree by dragging and dropping. The first bit, change the cursor into copy if we are dragging an item from outside into the inspector. And if we drop the item into the tree, then we iterate through them. And for each, we need to make sure that they're actually inherit from tech. And if that is so, we use the add node function to create a node containing this tech under the mouse cursor. This function already performs the check whether this technology already exists in the tree, so we don't have to worry about it. And let's see. There you go. Then we call the end scroll view. We could actually have it earlier, as long as we call it before the next GUI layout or editor GUI layout, it's fine. After that, the following code creates the vertical and horizontal scroll bars and set their position to the scroll position. Since they originally take their scroll position from the scroll position itself, it doesn't interfere with the scrolling when we use the middle mouse button. So it will be updated as we move anyway. And in the final section is so that we can delete a tag if we want. This is relatively simple. We create a horizontal section using the begin and end horizontal functions, and inside an if statement checking whether the selected node is assigned. If we have selected node, then it draws the delete tag button, which if pressed calls the delete node function from the target tree. This function doesn't remove the node from the memory though, it simply removes it from the tree. So the active node and the selected node could still be pointing this node. So we assign these to null to make sure that there are no loose ends left. And later, the garbage collection will delete this node from the memory, seeing that it is not referenced it anywhere else. And finally, the most important part, we need to call the SetDirty function for the target tree. This makes the changes that we make persistent. Otherwise, any change you make on the tree, you might think that it is saved, but once you restart Unity, it will go back to the original. And finally, you too have a TechTree or a skilltree, whichever you want to use, and you can modify it as you want. I try to keep it as succinct as possible, and I hope this was clear, but please don't hesitate to ask questions or leave a comment. And I don't know, maybe you can share your progress in the comments as well. And please subscribe so you won't miss the next. And please subscribe so you won't miss the next video. I can't say this thing. And please subscribe so you won't miss the next.
Please subscribe so you don't miss the next video.